As you continue your work on project number 2, you'll need to begin to analyze the data you collect from your surveys. Just to get a jump start on that, to ensure that you understand how to do some of those calculations, this video, will walk you through how to calculate the standard deviation of the numbers that you've collected from your survey. We're going to start with just looking at the first 10 responses. Even though your survey had 100 responses or will have 100 responses by the time you do your calculation, we're going to look at just 10 so that we can get a grasp on how to do the calculation to start with. What you see here on the screen is the formula for standard deviation. You don't need to memorize this formula, though after you've done a number of problems you may memorize it just because it's fallen into your memory. What we're doing when we calculate the standard deviation is finding the mean, and that is written in symbols as x bar, or x with a bar above it. And then what we do is we find the difference for each individual number, each of the numbers, the difference between that number and the x bar, or the mean. And then what we do is we add all those numbers up. Oh, I'm sorry, I forgot the square there. We square them and then add all those squares up. After we get that sum, what we're going to do is we're going to divide by however many numbers there are minus 1. So divide by 1 less than how many numbers there are. Since we're going to use 10 numbers, our quotient is going to be 9 when we do this practice. And then the last step is simply going to be to take the square root. One thing we want to be mindful of is not rounding until we get to the very, very, very last step. So it'll take a little bit of practice with your calculator to get to the place where you can get everything that's in this radicand. Radicand is just a fancy way of saying the expression or the number under the radical or inside the radical. But we want to get that radicand on our calculator in such a way that it hasn't been rounded yet, and then take the square root of that unrounded number. So let's get started. I have taken the question, how many times a month do you eat ice cream? By the way, did you know that the waffle cone became popular right here in St. Louis in 1904 at the World's Fair? So this is an excellent question for us to be working on at the St. Louis Community College. I've started by listing all of the numbers. That's this first column. And so I'm calling those numbers X's. So as I got results back from my survey and I looked at the first 10 surveys, I saw that for that question, how many times a month do you eat ice cream? I had responses where 2 people said they had no ice cream in a month. 1 person said that they had ice cream about once a month. 3 people responded that they had ice cream about 4 times a month. 2 people said 9. 1 person said 15. And 1 person said 27. But notice that I put these numbers in order, starting with the smallest and then going up from there. If a number was listed on the survey, if more than 1 person gave that answer, I listed that number twice. Next, I would find the mean of those x's. So as you can see here on the chart, I added 0 plus 0 plus 4 plus 4 plus 4 plus 9 plus 9, so on, and I got a total of 73. Because there were 10 x's, to find the mean, I divided by 10, and that is the x bar, or the mean. So x bar, and that, by the way, is the number we'll need for the second column. X bar for my set of data is 7 3/10. I'm not going to round that to 7. I'm going to keep it as a 7 3/10. The next step, so here we are in number 5, is I have completed the second column of the chart by subtracting each number. So let's start with a 0. minus the mean. And I get a negative 7 3/10. Notice that that's repeated twice. 1 minus 7 3/10 is negative 6 3/10. And then there were 3 times that we get a 4. So 4 minus 7 3/10 was negative 3 3/10. So I've listed that 3 times. 9 minus x bar. Now we're finally getting some positive numbers. 15 minus, oh, let me write the correct x bar. 15 minus x bar and 27 minus x bar, where I get these other numbers. 1 7/10 repeated twice, and then 7 7/10 and 19 7/10. So that completes the second column. Let's move on to the third column. I'm going to take each of those numbers and square it. Now, although I've done this in a by completing the whole row first and then the whole second, or rather the column, I completed the entire second column and then I moved on to the third column. Really, what I would have done, just to keep things simple, is I would have put in my calculator 0 minus 7 3/10, and my calculator would have given me negative 7 3/10. And then on my calculator, I would have put square, so that's that upside down caret on your calculator. I would have told it to square that number. And when I do that, it's implying my calculator is doing this. Sometimes, depending on what calculator you have, your calculator may or may not accept that negative 7 3/10 correctly, because your calculator may be calling it negative 1 times 7 3/10 squared, or your calculator may be doing this. But this, where we're squaring the whole number, including the negative, is what we want. So if your calculator spits out the answer negative 53 29/100, then you know that that's got to be wrong, because the square of a negative is going to be positive. All numbers should be positive in this column. So check your calculation and make sure your calculator isn't pulling a fast one on you. Make sure that you're getting a positive number. If you did get a negative number, that's okay. Just take the absolute value and change it when you write it. Write it as a 53 29/100 rather than writing the negative 53 29/100. Notice that I'm not calculating it every time. Instead, I can calculate this once and then notice that this is going to be a repeat. I calculated negative 3 3/10 squared, so that's negative 3 3/10 times negative 3 3/10 to get positive 10 89/100. But then I can write that same result 3 times. For 1.7 squared, I could write it twice, and so on. So make sure you're doing this column 3 with the most efficient method possible. But again, what I'll say is that it probably, in most cases, is going to be a little bit less work in the end if, instead of doing the whole column at a time, I take my 0 minus the mean and have that in the calculator and then square it. And get the 53.29 all at the same time. So I'd encourage you to do whichever method, whichever process works best for you, As long as you're certain that you're getting accurate answers, make sure you're doing either by row or by column first correctly. The next step is to add up all of the numbers in this third column. So I'm going to add these numbers. And you can see that the way I'm noting that is with sigma. So sigma means sum up all of those squares of x minus x bars. And when I do that addition, so I'm adding this column, when I do that addition, I got 632 and 1/10. That's just adding each of the numbers in that column 3. By the way, as you see the calculation, let me share with you a small shortcut you could use in adding these, especially when you go to add even more pieces of data, because in your survey you have 100 results. I have grouped them together, and instead of saying 53.29 plus 53.29 plus 39.69 plus and so on, what I've done is group them together, and on my calculator in one swoop I did 2 times 53.29 plus 39.69 plus 3 times 10.89 plus 2 times 2.89 plus 59.29 plus 388.09. Or in other words, I used multiplication and said 3 times 10.89 is the same as 10.89 plus 10.89 plus 10.89. Not only is putting this into the calculator in this way a little quicker, but it's also more efficient and is going to give me less opportunity for making a mistake. So anytime that you can find a way to be more efficient, we really ought to do that. Once I have that sum, 632 and 1/10, I'm ready to move on to step 8, which is dividing by 9. Now, as a side note, why are we dividing by 9? In this case, we're dividing by 9 because we had 10 x's. So if there are 10 x's, and that means that n, the number of x's, is 10, and 1 less than that is going to be 9, and that's why we're dividing by 9. So I have the 632 and 1/10 already in my calculator. I'm going to hit divided by 9, but be careful. Although you could write this number down, don't clear your calculator, because we want to take this square root of that whole thing, not a rounding of that answer. So on the calculator, I'm going to actually do this. I put 632 and 1/10 divided by 9 equals, and then I did the square root of that. Now, depending on how your calculator works, you might have had to put the square root first. So if that's the case, instead of using the square root button, we could use the fact that a square root is the same thing as taking that number and raising it to 1/2 or raising it to 0.5. So what I'm going to actually do is I'm going to put the caret bar and 0.5, meaning raise this answer to the 1/2 power, which is the same as square rooting. When I do that, I get if I round it, so the actual number when I did that was 8.380532998. But you can go ahead and round that to 2 decimal places. So round it to the nearest hundredth to get 8 and 38 hundredths. And if you were also able to get 8 and 38 hundredths, then you have followed this process correctly. Now, let me give you a tip. just a study tip, how to be a good student tip. Before you move on to doing this type of calculation with your own numbers, if you simply filled in this chart as we went along and you weren't able to do that without the guidance of this video, then I'd really recommend that you try it one more time from scratch. So erase everything you have in the chart and try this process one more time from a blank page and make sure that you're still getting the 8 and 3800ths. If you can get that 8 and 3800ths on your own, then you know you're ready to move on to part 2, doing the standard deviation with the numbers in your surveys.